Good morning, class. My name is Sarah, and I'm going to be performing experiment 5 with empirical formula of magnesium oxide today. So the first thing we're going to do is we're going to obtain the ring stand, the Bunsen burner, the O-ring, the crucible, the triangle, and the lid. Then we're going to heat the crucible and the lid for about 5 minutes to get rid of any impurities that from our hands or from anything that was in it from before. And after firing is complete, we're going to cool the crucible and then obtain the mass. Use your tongs, or you can use your imaginary gloves. Okay, so when I measured the mass of the crucible with the lid, it is 25.9 grams. Then we're going to clean a small ribbon of magnesium with steel wool and weigh out about 0.10 grams. And here is our steel wool. And it's about 10 grams worth of it. So then we're going to roll the ribbon in a coil and place it into the crucible. Okay. Then we're going to weigh the crucible, the lid, and the magnesium in it, and then we're going to record the mass. So after we record the mass of that, we get 26 grams. Now, to measure the mass of the magnesium, all you have to do is take the mass of the crucible with the magnesium and subtract it from the mass of the crucible, and you get 0.1 grams. To convert it to moles of magnesium from mass of magnesium, all you have to do is take the mass, which was 0.10 grams, times the 1 mole divided by the atomic mass of the actual magnesium, which is 24.31 grams, and we get 0.0041 moles. Okay. Then we have our ring stand and whatnot, and we're going to gently heat the magnesium in the crucible, slightly uncovered, for roughly 7 minutes. The magnesium can oxidize rapidly in excess air, so we're gonna make sure we don't let too much air get in. Then we're gonna remove the lid periodically. Remember, these are my gloves. We're gonna remove the lid periodically to check for a reaction. And then the reaction should look like this. Okay? It should look shriveled up, kind of white and ashy like. So since we removed the lid periodically and saw the reaction, we're gonna remove it and let it cool now. And then we're gonna measure the weight of the crucible, the lid, and the new product. And so when you measure the crucible, the lid, and the new product, we get 26.6 grams. Okay. Then we're going to measure we're going to reheat for about 7 minutes to make sure that the magnesium is completely oxidized. And that's how we can tell it's completely oxidized, by the white appearance. And then we're going to repeat steps 7 and 8. We're going to remove it again and let it cool. And then measure the weight of the crucible, the lid, and the new product, which is 26.6. And we're going to do that one more time as well. So for all 3 trials, if we measure it accurately, we should all get the same amount, which is 26.6 grams each time. Okay. Then we're going to, we're going to keep reheating and cooling until we get 2 readings, or 2 or 3 readings within 0.01 and 0.02 of each other. And luckily for us, we've gotten all of them. Now, to get the mass of the product, what I did was I took the mass of the crucible after heating, and I subtracted it from the mass of the actual crucible, and I got 0.7. Then the mass of the oxygen added, we took the mass of the product, which is 0.7 grams, and subtracted by the mass of magnesium, which is 0.1 grams, and we got 0.6. Now, to get from the moles from mass, all we have to do is get 0.6, and then we times it by 1 mole, and divide it by the actual atomic mass of oxygen gas, which is 2/16, which is 32, and we get 0.018 moles. Then here's our mole fraction. We set it up by 0.041 divided by 0.0041. Same for oxygen. And then these are the totals that we get. And then this is the empirical formula, which is magnesium 1, oxygen 5. Thank you.